Okay, Ji, after discussing the generic DBMS architecture, now we will discuss the implementation alternatives. So, if you want to implement a database management system or DBMS in any situation, so you have various alternatives. There is not one alternative that you have to do this in that manner. So there are various alternatives. So these in this diagram, these alternatives are represented in terms of three important you can say dimensions. One dimension is called heterogeneity, and second one is called the autonomy, and the third axis you can see over here is distribution. So on the basis of these three dimensions, they have developed various options which are possible. uh, we know about autonomy. Autonomy means how much that particular application is has a freedom to perform its own functions, perform its own applications. So that refers to autonomy. And when we talk about heterogeneity, it refers to that it refers to basically three different kinds of heterogeneity. So maybe heterogeneity in terms of DBMS, heterogeneity in terms of operating environment, or heterogeneity in terms of, let's suppose, the hardware itself. And the third dimension is distribution, that how it will be distributed. So keeping all these three dimensions into the mind, if you go for purely distribution perspective, then you have a slot for peer-to-peer databases. And when we talk about peer-to-peer networks or peer-to-peer database systems, it means we want to say that the connectivity we have, where every client and where any node can act as a server. So that is the concept of peer-to-peer database systems. And if the second option you have, you can see in this cube, is client server system, and based on the client server model, where we can have a server and where we have the clients. So that is a general model normally we use and implement in various enterprises to handle the data. So we have the client server systems, and then we have the multi database systems. So it means not a single database. There are multiple databases which are connected. So therefore, जिस जो एरो जहां रेफर कर रहा है वो डायमेंशन अगर आप देखें तो उसका मतलब है it is more autonomous because multi databases are functioning. So it means so every database in that particular system has an autonomy, has more autonomy. When we talk about purely a client server system, so yes, there can be heterogeneity. It can be heterogeneous, and of course, it is distributed as well. But let's suppose we talk about multi-database system. So we have the distribution, we have the autonomy, and as well as heterogeneity. All these three things comes in that particular sort of an implementation. So it all depends that how you come out with an implementation plan. So it is not a fixed criteria. It is based on the requirements you have. Let's suppose if we are interested to implementing such a system, we have to analyze the given information, the given data, the given environment, and then we can suggest that what is the best alternative in the given circumstances. Okay, so but there are various alternatives. So distribution, as we have discussed, that whether the components of the system are located in the same machine or not. That is basically the concept of distribution. So if it is more than one machine, then it is distributed. Heterogeneity, as I discussed earlier, is it at various levels. So there may be a hardware heterogeneity. Let's suppose we are using various kinds of servers, not with the same specification. So if we are doing so, again, you can say that it is heterogeneous based on the hardware. Similarly, it can be heterogeneous in terms of communications. It can be heterogeneous in terms of operating environment. It can be heterogeneous at DBMS level. Let's suppose you talk about the data models. So we have not a single model. So we have various data models. So let's suppose if one database is implemented in one model and another database is represented in another model, then we want to integrate them. So again, it involves heterogeneity. Okay? Autonomy, sometimes difficult to understand what autonomy is. But autonomy basically can be defined in various ways, and actually it can be categorized as design autonomy, communication autonomy, and execution autonomy. So there are three possibilities of autonomous behavior here in the applications. Number one, design autonomy, ability of a component of a DBMS to decide on issues related to its own design. So if we have various components and if we want to have a change, then the component itself absorbs the change. So there is no dependence on the other designs. There is no dependence on the other integrated databases. So design itself is, you can say, is the right of that particular component, that it can be changed, it can be altered. Communication autonomy refers to the ability of a component to decide whether and how to communicate with other DBMS. So whenever we are talking about such an environment where components are interacting with each other, so it is quite obvious that we need data from other components as well. So whether the components can communicate directly to all those components which are there in the system, or we have some centralized communication. So if we have some centralized communication and the component has no right to communicate with the other, it means the communication autonomy is compromised. So here, when we talk about communication autonomy, it means the component should be allowed. There must be an ability of the component to decide at their own कि भाई मैं इससे communicate कर सकता हूँ, मैं दूसरे component से communicate कर सकता हूँ. क्यों communicate करते हैं हम इस environment में क्यों communicate करेंगे? Obvious बात है कि मुझे data required होगा जो उस component के पास है. मैं एक ऐसी application run कर रहा हूँ कि वो सारा डेटा मेरे पास नहीं है, वो दूसरे कंपोनेंट के पास भी. दैट इज व्हाई. और कम्युनिकेशन, अगर ये डायरेक्ट कम्युनिकेशन होगी और कंपोनेंट्स को हम अगर वो डील कर सकते हैं, तो इसका मतलब है इन टर्म्स ऑफ द मॉडल वी हैव द कम्युनिकेशन ऑटोनॉमी. एंड थर्ड इज कॉल्ड एग्जीक्यूशन ऑटोनॉमी, ability of a component to execute local operation in any manner it wants to. Okay, for execution there is no dependence on the other components. The component itself has the power. The component itself has the ability to execute the local operations. So there is no need to intervene in the in one component, or the other component may intervene into it. No. So DBMS को अगर execution करनी है किसी चीज की और वो locally defined है, तो वो खुद ही perform कर सकता है. उसको किसी से इजाजत लेने की जरूरत नहीं है, उसको एग्जीक्यूशन के लिए किसी और की परमिशन की जरूरत नहीं है. तो ये सब चीजें किस चीज में हेल्प करती हैं? ये जो मैं तीनों चीजें बता रहा हूँ, ये ऑटोनॉमी अगर होगी तो द सिस्टम्स विल परफॉर्म बेटर देन द यू कैन से योर ऑप्टिमाइजेशन में बी अचीव्ड. यू विल हैव अ बेटर रिजल्ट्स ऑफ योर एप्लीकेशन. जितनी ज्यादा याद रखें ऑटोनॉमस होंगे सिस्टम्स, उतना बेहतर रिस्पॉन्ड करेंगे. जितना सिस्टम जो है वो फेडरेटेड होंगे या जितने सिस्टम जो है वो डिपेंडेंट होंगे, उतना कम्युनिकेशन बढ़ जाएगी. जितनी कम्युनिकेशन बढ़ जाएगी आपकी कॉस्ट बढ़ जाएगी. तो वो जो आप चाहते हो ना कि मैं एफिशिएंट और इम्प्रूव परफॉर्मेंस, जो हमने पहले लेक्चर में पढ़ा, दूसरे में पढ़ा, ये सब चीजें आप अचीव नहीं कर सकते हैं unless you have the design economy, अगर आपके पास ऑटोनॉमी नहीं है. Now this model is called a simple client server architecture. So here we are talking about various kinds of architectures, and this architecture is very common architecture. And आप लोगों ने अगर fourth year में आ गए हैं तो माशाल्लाह you have gone through with all those architectures in various courses. But here, okay, we are talking about specifically database systems. So you can see a client server architecture. So there is a client side and there is a server side. So first divide the side into two, client side and server side. Now first see the client side. So what is the requirement at the client side? So clients are those you can say users who connect to the system. So connect to the server for what? For various kind of services. So what we offer at the client side? So obviously the client side needs an operating environment, because the client need to interact with the system. Let's suppose you're talking about a network operating system. So we have a network operating system so that a client can easily communicate and process various activities. Then client must have a user interface. So if you at the client side, you must have a user interface. How you will connect to the database, how will connect yourself, how you will authorize yourself. Obviously, you need an interface. So for the interface, then you can enter the data, you can generate the queries, you can see the results, you can make an update operation, you can have a read-only operation, blah, blah, blah. So you need an interface. Normally, we define interfaces for the users, for the clients, based on their requirements. And those interfaces may differ from various kinds of clients. But here we are talking about a client server architecture. So it is enough for us to know that there must be a user interface when we talk about client server architecture. Then we need an application program. Of course, a lot of applications run at the client side. So client want to perform various applications, so client can do it. तो ऐसा तो नहीं है ना कि सारी एप्लीकेशंस के लिए वो सर्वर पे जाएगा, नहीं, बल्कि बहुत सारी एप्लीकेशन अपने एंड पे रन कर सकता है. और वो कितनी एप्लीकेशंस हो सकती हैं डिपेंडिंग ऑन योर ओन मॉडल, योर डायग्राम, आपकी जो रिक्वायरमेंट्स हैं उन पे डिपेंड करता है. एंड देन इट नीड्स अ कम्युनिकेशन सॉफ्टवेयर, and that communication software, of course, when we talk about a database system, that communication software itself is based on, if we talk about a relation product, it is based on SQL, and if you are talking about object oriented, it is based on OQL. So here, let's suppose we are talking about a relation environment. So how user communicates through SQL? When I say through SQL, it does not mean that they have to write an SQL queries, but we design forms for them, we design interfaces for them, and from those interfaces they can directly have queries. But whatever the query they will generate, actually a SQL query is being generated, because actually that interface, connecting interface, is basically the query language that is based on SQL queries. And then we have the server part. You can see the server part. So server part also requires a communication software. So SQL query is being generated and SQL query has been intercepted. So both need the communication software. ये बिल्कुल ऐसे ही है कि जैसे मैं और आप आमने सामने हम बात कर रहे हैं, तो मैं बात करूंगा, जो मैं बात करूंगा वो आप अंडरस्टैंड करेंगे, आप जो बात करेंगे मैं अंडरस्टैंड करूंगा. तो मेरे और आपके दरमियान एक मीडियम है, वो लैंग्वेज का मीडियम है, ठीक है. एंड वी कैन हियर, हम आवाज सुनते हैं, पहचानते हैं, और लैंग्वेज का मीडियम है, तो मैं और आप कम्युनिकेट करते हैं. सिमिलरली, फॉर एग्जांपल, वी आर यूजिंग Zoom right now, but Zoom is a video conferencing tool. So here there is also a communication software at your end, at my end. So that's why we are communicating. So similarly, if let's suppose a client want to generate, जैसे किसी भी ऑर्गेनाइजेशन में लोग अकाउंट्स में बैठे हैं, वहां से क्वेरी जनरेट कर रहे हैं, उसी ऑर्गेनाइजेशन में लोग HR में बैठे हैं, वहां से क्वेरीज को जनरेट कर रहे हैं, उसी में मैनेजमेंट पोजीशन पे लोग बैठे हैं, वहां से वो क्वेरीज जनरेट कर रहे हैं. And of course that those queries will be intercepted by the server, and there we have the semantic data controller, which we talked about earlier. There we have the query optimizer. ये main function है database के. Semantic data controller has the responsibility to evaluate whether the query is semantically correct or wrong. Then query optimizer. The main function of query optimizer is to optimize the query so that make such a plan which is minimal cost based. So we have to generate. So there are various trees. Various trees can be generated, but we have to pick the optimal one. We have to pick the optimal path. And for query optimization, we have various query optimization algorithms. So those algorithms are also implemented whenever talk about any DBMS product. Then another important component is called transaction manager. Transaction manager is responsible for handling all those database transactions, because whenever I say a database transaction, it means transaction is defined in terms of bundled activities, not a single activity. So in database terms, we call it database transaction is a transaction which involves a set of activities. Let's suppose you want to take an amount from one account and you want to take an amount of another account, and then you want to send that amount to another account. So it means you are handling various activities. You are handling, it involves various steps. But you want to bundle it. That is important. वरना तो मैं एक सिंपल क्वेरी करूं और मैं अमाउंट देख लूं, तो ये एक सिंगल क्वेरी कहलाती है ना. लेकिन जब हम मल्टीपल चीजों को कंबाइन करते हैं किसी एक पर्टिकुलर टास्क को अचीव करने के लिए, ठीक है, तो फिर ये डेटाबेस में हम क्या कहते हैं इसको, ट्रांजैक्शन, डेटाबेस ट्रांजैक्शन. एंड डेटाबेस ट्रांजैक्शन, फॉर डेटाबेस ट्रांजैक्शन इट इज वेरी इंपॉर्टेंट that a transaction is either fully done or it is not done. There is no concept of half done, because transaction involve multiple activities, and as you know, the multiple user are accessing that data, so you cannot block the data. तो ये तो नहीं हो सकता ना कि मैं हाफ डन करके ब्लॉक कर दूं. तो जब मैं हाफ डन करके ब्लॉक कर दूंगा तो वो डेटा डर्टी डेटा कहलाएगा, डर्टी टेबल कहलाएगा. तो जो बाकी लोग वेट कर रहे हैं इसको प्रोसेस करने के लिए, वो क्या करेंगे. तो ट्रांजैक्शन इसीलिए परफॉर्म होती है. तो ट्रांजैक्शंस को मैनेज करने के लिए पूरा एक ट्रांजैक्शन मैनेजमेंट का पूरा एक कॉन्सेप्ट है. तो ट्रांजैक्शन मैनेजर इज देयर टू हैंडल दोस ट्रांजैक्शंस सच दैट देयर विल बी नो कॉन्फ्लिक्ट, such that every user can easily access the data, such that concurrency can be maintained. Otherwise, अगर ऐसा नहीं हुआ तो various people can stuck, deadlocks can appear. Transaction manager अगर अपना रोल नहीं प्ले करेगा, मैनेजमेंट हम नहीं करेंगे, तो फिर डेडलॉक क्रिएट हो सकते हैं, और डेडलॉक क्रिएट हो जाएंगे तो फिर हम यूजर्स को सर्विसेज नहीं प्रोवाइड कर सकते, ब्रेकअप आ जाता है. देन देयर इज रिकवरी मैनेजर. Recovery manager is always there. Whenever we are dealing with the data, there is always a possibility that we lost the data. There is always a possibility that we can lose the data, maybe by some physical damage, or maybe some damage which is caused by software, or sometimes it is intentional and sometimes it is unintentional. So in any ways, there is a possibility that we can lose the data. So it means we need to have a proper backup plan. So for every database system, wherever we are talk about any organization, wherever जहाँ भी database चल रहे होते हैं, वहाँ उनके पीछे पूरा एक backup system चल रहा होता है. क्यों चल रहा होता है? Because at any given point in time, कोई भी ऐसा सिनारियो क्रिएट हो सकता है जिससे हम डेटा लॉस कर सकते हैं या ब्रेक डाउन आ सकता है. तो अगर ऐसी सिचुएशंस अराइज होती हैं, then you have a recovery plan, how quickly you can recover the data. तो डेटाबेस में एक पूरा कंपोनेंट है. जब हम डेटाबेस का कोर्स करते हैं या डेटाबेस में हम सर्टिफिकेशन पे जाते हैं, तो उसके अंदर बैकअप एंड रिकवरी एक पूरा सब्जेक्ट है, और विच इज़ वेरी इंपॉर्टेंट स्पेशली इन टर्म्स ऑफ डेटाबेस एडमिनिस्ट्रेशन. तो डेटाबेस एडमिनिस्ट्रेशन की अगर आप बात करें तो उसमें तो बहुत ही इंपॉर्टेंट है, उसमें ये एक पार्ट है, कोर्स है. और फिर रन टाइम सपोर्ट प्रोसेसर हमें चाहिए. रन टाइम के ऊपर जितनी प्रोसेसिंग परफॉर्म हो रही है उसको मैनेज करना और उसको हैंडल करना, that is also the responsibility of that server side, and that then it is linked with the database. So that is your database, which refers to your data which is being stored. So that is the way the client server architecture works. Advantages of client-server architecture. What are the advantages? Number one, more efficient division of labor. Oh, fine, that is good because we have efficient division of labor. So we exactly know what client has to do, what server has to do. We can go for horizontal and vertical scaling of resources. Yes, we can do it. Better price performance on client machines. Yes, because client machines are more powerful machines nowadays, and lot of applications which we can perform on the client machines. So now it is available in less prices, so people are going for it. So it's a good model. Ability to use familiar tools on client machines. Yes, there are lots of tools which are available and easily downloadable, easy workable, and people can use it, and that can be integrated with your systems. मिसाल के तौर पे आपने प्रोजेक्ट मैनेजमेंट की एक्टिविटी ऐड करनी है, आप ऐड कर सकते हैं. आपने प्लानिंग की कोई एक्टिविटी ऐड करनी है, वो आप ऐड कर सकते हैं. सो नो प्रॉब्लम. Client access to remote data. Of course, client can access the remote data as well because let's suppose the data is not there at the client side, it's somewhere else. So we in a client server model, client can easily access the remote data. Full DBMS functionality provide to client workstation. Yes, we can provide all those functionalities of a DBMS, which are the core of the DBMS to the client workstations. And of course, it leads to a better system price and performance. So बेहतर होगी performance, improve होती है. Instead of कि अगर मेरे client side पे ये सब activities ना perform हो रही हो, तो फिर तो performance decrease कर जाएगी. इसमें क्या होती है, improve कर जाती है. And you can see the same model is represented in terms of a database server, and here you can see that we have three layers. One is the client, second is the application, and third is the database. So on a network, the client generates the queries and the application server is responsible for handling those applications. And after handling those applications, that application was sent to the database server, and on the database server, let's suppose a data is being received from the database, your storage, and provide the answers. तो बिल्कुल ऐसा होता है ना, जैसे मेरे पास एक वेब सर्वर होता है, वेब सर्वर से आप कनेक्ट करते हैं, वो वेब सर्वर जो है ना, फिर मेरे पास एप्लीकेशन सर्वर है, फिर मेरे पास डेटा सर्वर है. तो ये कनेक्टिविटीज हम इस तरीके से फॉर्म कर लेते हैं ताकि हम एप्लीकेशंस को अलग हैंडल करें और डेटाबेस को अलग हैंडल करें. सो इन दैट वे दैट एक्चुअली वर्क्स. नाउ वी टॉक अबाउट डिस्ट्रीब्यूटेड वन. ये वाली जो डायग्राम थी ये डिस्ट्रीब्यूटेड नहीं है. यहाँ हम सिंपल एप्लीकेशन सर्वर की बात करें, एक डेटाबेस सर्वर की बात करें. What is different in this diagram? You can see yourself. Here we are talking about distributed database server. So in a distributed database server, you have more than one application server. You can see yourself, and you also have more than one database server. You can see in this diagram as well. So various clients are connected, and there are maybe two or more application servers, and there may be more than one database server. So that is the difference between a distributed database server and a single database server, as you have seen in the previous diagram. ठीक है, and we'll move forward. आगे चलते हैं, ये भी clear है. Now, that is called Datalogical Distributed DBMS Architecture. अभी याद है हमने 3 schema architecture देखा था, उसको ज़हन में लाएं. 3 schema architecture में मैंने क्या बताया था कि we have the external schema, we have the conceptual schema, and we have the internal schema. Same cheese, same thing is here, but a bit in a bit different form. एक ही चीज है लेकिन थोड़ा सा different form में. क्या है different form में? क्या है different form में? और सबसे पहले ऊपर देखें. We talk about the external schema, but since we are talking about distributed environment, so we do not have one schema, external schema. We may have more than one external schema. So that is why only what has changed on the top, you can see external schema 1, external schema 2, ... external schema n. Why? Because here we are talking about a distributed environment. So we're not talking about a single external schema. There may be more than one external schemas for various, क्योंकि एक database application मेरे पास लाहौर में चल रही है, उसका external schema different हो सकता है. एक application मेरे पास कराची में चल रही है, उसके लिए जो मैंने external schema create किया वो different हो सकता है. Now all these are you can see connected to GCS. GCS stands for Global Conceptual Schema. It stands for Global Conceptual Schema. Always remember. So in a distributed environment, you need to have a global conceptual schema. Why? Because आप कहते हो कि आपने डेटाबेस को डिस्ट्रीब्यूट कर दिया, ब्रेक कर दिया हॉरिजॉन्टली या वर्टिकली, यही हम बात कर रहे थे ना। और लेट सपोज वो 3 जगहों पे तोड़ दिया आपने, तो अगर मैंने 3 जगह पे ब्रेक कर दिया और तीनों के दरमियान कोई रिलेशनशिप बिल्ड नहीं किया, तो ये तो फिर तीनों आइसोलेशन में चले गए ना। तो फिर मैं कैसे कंबाइंड क्वेरीज जनरेट कर सकता हूँ? मैं नहीं कर सकता ना। तो देयरफॉर we need to have a global conceptual schema which involves all the local schemas. So let's suppose I've broken the database into 3 components. Let's suppose one is Multan, one is Lahore, and one is Karachi. So Lahore has its own local conceptual schema. Multan has its own local conceptual schema. Karachi has its own local conceptual schema. Okay, but all these schemas are integrated, are defined in terms of global conceptual schema. Because अगर मैं तीनों को ब्रेक कर दूंगा तो ये तीनों के दरमियान कोई रिलेशनशिप नहीं रखूंगा, तो फिर मैं कैसे हैंडल करूंगा? ये बिल्कुल ऐसे ही है कि जैसे तुम लोगों के बीएस के 4 इयर्स होते हैं और मैं ये कहूँ कि फर्स्ट ईयर को मैं अलग रखूंगा, सेकंड ईयर को अलग रखूंगा, थर्ड को अलग रखूंगा और फोर्थ को अलग रखूंगा, और उनके दरमियान में इंटीग्रेशन ना क्रिएट करूं। तो जब उनके दरमियान इंटीग्रेशन नहीं होगी तो वो एक अपडेट 1 में हो रही है, वो 2 में को पता नहीं है कि 2 में कैसे होगी, 3 को नहीं पता, 4 को नहीं पता, लेकिन इंटीग्रेशन होगी तो इसका मतलब है कि मेरे पास एक ग्लोबल कॉन्सेप्चुअल स्कीमा एग्जिस्ट करता है। और एवरी लोकल कॉन्सेप्चुअल स्कीमा हैज इट्स ओन लोकल इंटरनल स्कीमा। जब हम सिंपल मॉडल की बात कर रहे थे जो कि डिस्ट्रीब्यूटेड नहीं था, तो वहां पे इंटरनल स्कीमा एक ही होना चाहिए था। यहाँ पे याद रखेंगे कि जितने भी कॉन्सेप्चुअल स्कीमाज हैं, उन तमाम कॉन्सेप्चुअल स्कीमाज के अगेंस्ट मेरे पास क्या होंगे? मेरे पास इंटरनल स्कीमाज होंगे। ये है, that model is actually called Datalogical Distributed DBMS Architecture। ठीक है,